He's working at Blockstream and is mostly working on simplicity and Miniscript. And that's also what he's going to talk about, Miniscript. So please, welcome Sanket.
Okay, good morning, everyone. Today, I'll be discussing Miniscript, which is a work that Peter Wola, Andrew Polstra, and me, and with input from many Bitcoiners, did in summer 2019 when it has been iterating constantly, but now it's in a fairly stable state to share and hopefully get more deployment across. So the title is Miniscript, Composable, Analyzable, and Smarter Bitcoin Script. So to just a brief background, I think the person who introduced me correctly recapped those. If you're interested in any of these things, feel free to reach out to me after my talk, and we can chat more about these things. So just to motivate Miniscript, I want to discuss what are the problems with Bitcoin script today. And thinking of just at a super high level, when Satoshi designed Bitcoin, it was it's a really big step to think about, no, I'm not going to pay a person, but this script pays to a program which you can satisfy. And so this kind of gave rise to a notion of script where you have some instructions to execute or a computer program to run, which is run by all the different network participants to see whether a certain transaction is valid or not. But the design, in principle, has few issues. First off, it's hard to reason about. So I know a lot of us Bitcoiners correctly advertise the fact that it is limited in expressive power. But even if it is limited in expressive power, we just don't know how to analyze script. If I give you some sample random bytes, you just don't know whether that is, you just can't semantically analyze it. And that is, I think, until we have something like Miniscript deployed, Bitcoin is just something where you pay to a person, where this is a more general composable framework. It is difficult to use, and almost all tooling where you have a Zappo wallet or any complicated, even multisig. It's a shame that when we say multisig, we have to associate a complex word with it, but it's not, conceptually speaking, it's not that complicated, but still you have all custom tools for Miniscript. You have a 3 of 5, you want to change that to something else, then you need to have Bitcoin experts to analyze different things. This is a well-indented example from Bolt3, which is one of the Lightning HTLCs. And we'll go through this example later, but this is just copied as it is. But you can see that it is, looking at this, it's not really easy to see what this is trying to do. Surely you have experts who can look at this and figure out what this is doing, but it is slightly, it is not that easy to figure out what the script is doing. We have someone? Anyways, so I'll just continue. Hopefully I have memorized things correctly. Anyways, the other issue with Bitcoin script is that if you want to argue correctness of the script, as this talk, let's just first focus from the perspective of a user. You're not a wallet developer, you're a Bitcoin user, and you want to custody your coins. There are a few things that, custody your coins into a complex script for better security. There are a few things that you want to have good semantic answers for. The first of them is if I have access to certain keys, let's say my cold key and some other keys, can I always spend this complicated Bitcoin script? If I give you some script blob today, it's not that easy to figure out whether that is correct or not. And you want to be sure that as long as I have these keys, no one can steal my coins. Even though you are engaged in a complex multi-party setup, you just can't analyze these things today. Secondly, you might also be interested, these keys should not ever spend my coins unilaterally. If I am in a multi-party contract with one other participants, and they have these keys. Given a script, you want to be able to reason about things where the person them alone cannot spend these coins unilaterally. Other things which you are interested in would be malleability vectors. For example, with segregated witness, like SegWit opcode as it is, SegWit upgrade, we solved most common third-party malleability, but it is still possible to write complex Bitcoin script which are inherently malleable, where if you don't program things correctly. And you want to know statically whether all possible satisfactions, all possible spend paths for this script can be spent without, in a single way, so that they can't be malleated by anyone. It would be a big problem, for example, if you're spending a transaction and you set some fee for it, assuming that the satisfaction is 100 witness V bytes, and someone malleates it, and it is 10,000 witness bytes, and your transaction is not confirmed. And if you're relying it on some layer 2 protocol, then suddenly it becomes a security issue, where if your transaction is not confirmed in time, you can't analyze these things. This is most important. If I had to highlight one thing which Miniscript provides is composition. So currently, you just cannot compose script policies. If you have, Stefan did address some of those, did highlight some of these things. But if you have, say, one Bitcoin Core wallet, one Green wallet, one any other wallet, your favorite wallet, maybe a hardware wallet, and you want to have a call policy where you want to have 2 of these 3 keys, and let's say Green wallet has internally its own time lock. You just can't write today. With today's tool, you don't have any way to compose these scripts correctly. Compose the scripts in a high-level tooling way. You need Bitcoin experts to understand things and write them for you. And then again, it just becomes a one-time tool which only works for that particular script template. So we want to argue, we want to construct Miniscript so that for all possible, for most interesting use cases, you have this generic composability, and you can sign for things where your wallet should only care for part which they are interested in, and you have all the other stuff that they don't really need to understand. They just need to semantically know that whether this policy is acceptable to me. If hardware wallet needs to know that without my keys, the policy, the script cannot be spent, and everything else you can, and you just need to provide a signature. You might also want to check other things like change outputs and so on, but that is roughly you have a structured way to reason about Bitcoin script, whereas previously it was more just some opcodes which you wanted to execute. And with this, let's try to just rethink Bitcoin script so that we don't have these problems. We cannot get rid of Bitcoin script. It is there, it is consensus code, so unfortunately, we are stuck with it. But can we do something smarter with the things which we already have? For this, let's look at what people use Bitcoin script for. So the 3 things which people use Bitcoin scripts is public keys, where you do signature verifications. You have hash locks, which is some basis for Lightning Network or HTLCs or any other swap protocols. And you have time locks, where you have an absolute time lock or a relative time lock, which specifies after some time you want to spend or at some time you want to spend some funds. And you want to compose these things. So you want to say where public key 1 and this hash lock, or either this time lock or this public key, or maybe you have a threshold, which is kind of in between, where you say you need 3 out of 5 things to satisfy this fragment. And so let's just look at, just to get familiar with things, let's look at some simple policies, where you have the first thing just indicates that Alice should be able to spend the output, which is just PK Alice. If you have some 2 of 3 wallet, you would have a threshold with 3 keys, which is P1, P2, P3. Or if you have something complicated where a cosigner like Green wallet, where you would have a key. Like you can encode these things which are not like in a textual format, which are not Bitcoin script, but are the way in which you think about Bitcoin script. So like you would have something where if the other cosigner signs, if the user U or the green cosigner signs, then you can spend the policy, spend the output, or the user after some 90 days can spend the policy. And some other complicated things where you have like the liquid signing, like the sidechain control funds, which you have functionaries which are like 11 or 15 multisig. And if they don't respond, then you have a 4-week time block, after which some emergency keys can be used. So policies are just like the most basic way, if you ask someone how would they use Bitcoin, that is the way they think about things. So let's just like see what is Miniscript with respect to script. So Miniscript is Bitcoin script. So we have Bitcoin script, but we just want to think about it in a different way. Technically speaking, it's like a subset, but we have some structure in it. So with stack-based languages and just random opcodes thrown in there, you don't really have any notion of any structure to it. But if you have like programmed, the entire like programming relies on trying to compose things, trying to understand things locally, and you want to build a bigger, complicated program based on smaller components. You want some generic signing, where you have some complicated policy, and if, for example, this is a 2 of 3 multi, where which is like this thing, which is a 2 of 3 multisig, where either A, B, or C can spend it, or after some time, let's say this is a 10 blocks for simplicity, 10 block CSV, the E, like some emergency key can spend it. So you have, this is the same Bitcoin script which you would like write using Bitcoin opcodes, but instead of thinking about it in a Bitcoin script raw byte format, you think about it more you encode that in a more structured way. And because you have structure, things are just easy to semantically analyze. Like looking at this, it is easy, like just looking at this, you can easily say whether like where it's an OR, and if I have A and B, I can spend these things. And because you have structures, you can write software which like operates on the structures and can give you, can answer things like if I just have the emergency key, and if nothing has, like if no blocks have passed, or if this is 0, then can I spend it? And then this can output things for you. But previously, you just didn't have any of, like without Miniscript, doing this is just kind of one-off tooling. So there are some like weird things where we have like the D here, B here, VC here. Those are some like technical details about how you want to use Miniscript, rules for composition. But when we use this, we don't really, like users can just ignore these things. Those are for people who want to like write Miniscripts, but if you want to semantically analyze your Miniscript, what it is trying to do, you can just you can just ignore those details. Secondly, okay, I'll just sign on. Yeah, so those things are written in short, and all of this PKH is just a key. You can just assume those to be individual components, and you don't have to deal with. I'll just use this so that it doesn't happen again. So you can just forget that those things exist when you're trying to analyze Bitcoin script. So technically speaking, like Bitcoin script is, like Miniscript is Bitcoin script. Like the idea that you can, write a high-level language is not something new. Like people have thought about these things previously. There have been compilers which have been written, but the unique thing, there are a couple of unique things about Miniscript. First, it is script. It is not getting compiled into some other language. If you are given a script, you have a one-to-one mapping between Bitcoin script and Miniscript. If you give a script, you get a corresponding Miniscript. You have Bitcoin script, Miniscript, you get a Bitcoin script. But even though the underlying thing is same and the interpreter is executing it the same way, it represents a different, different way to think about things. So, like for a good vision for like the Miniscript project would be, instead of like the developer should just forget that there is a stack. There is some instructions that you want to execute. Like there is an multi-check sig add, which takes in 3 parameters and does so-and-so things and updates the adds 1 if it's something like this. You should just think about, oh, there is a multi. And what I just need conditions to satisfy. Instead of some instructions to execute to the script machine, we want to think in terms of what conditions do I need to satisfy to execute these things. And all the underlying work for converting Bitcoin script to Miniscript and like Miniscript to Bitcoin script is done by the Miniscript stack itself. Users or developers should just think about like what they care about. Presumably, like you yourself know, like as a developer, you know what threat model you're aiming for. So you should expertise towards that and let Miniscript handle things like how you want to describe or how you want to encode things into script. And instead of like a stack-like approach, Miniscript has more like a functional compositional approach, which really helps us do these things in a structured way. So these are just some basic examples of how like Miniscript translates to Bitcoin script. And like the fragments are constructed in such a way so that you can always like go back and forth between those two things. There's no ambiguity. So like for example, PK would be like PK just translates to key. PKH is popularly known PKH fragment, where you do like opt-up of Hassan 60, and you don't do the check sig, but it's just pushing the key onto the stack. Then you have different ways of doing ORs. But the key idea here is you don't need to semantically understand script. You just ignore the D, V, all these rules. Those the compiler would like the Miniscript, like the Miniscript encoder or Miniscript would help you figure out how do you need to compose these things to create a correct script. But when you want to semantically analyze these things, it's much more easy to analyze these fragments. So there are, at a very high level, Miniscript has, for each expression has some base type. It has some attributes, some wrappers to convert one type to other type, and some combinators to combine these types. So think of it like a programming language. It's a very rough analogy. But then you have different types, and there are rules of how you want to compose these functions together. And these rules are determined by a Miniscript type system. And in order to convert between those two types, you have these wrappers. So engineers can look at these things, and it's not like terribly hard to figure out how you need to compose these things. But you can write Miniscript by like you construct a policy, and then you can write Miniscript which represents the Bitcoin script such that the policy is mapped one-to-one. You just figure out how you need to compose things. Or you can write tools like compiler tools which just operate on policy and output Miniscript. So just to give one concrete example where you see like Miniscript, the full power of Miniscript is when you want to have like some generic signing or a composable script. We talk a lot about like multi-sig, and like that is, people just say that's a complicated script. And the reason is like we have all custom tooling around it. So today, if like you want to participate in a Thresh 3.4, like a 3 or 4 setup, all participants, let's say you're a big company and you're doing this like custody, and I am one of the participants, say C, and I have my own custom setup. I just don't want, for the same reasons you have a multi-sig, I don't want my own single key to be to be just one thing which I write down on a paper wallet. I also want that to be some multi-sig or another complicated protocol. But to do that today, all of these things need to understand like what exactly the script template is. If you look at like wallets code, like some wallets, you just have look at this byte at this much index and then figure out this is the public key and so on. So those things don't directly compose nicely. But if I want to have some policy where I'm allowed to do something like, okay, this is my own threshold, and I have this own setup with me. But if and all these other guys should not really, they should not really force my policy onto me. I might have my own policy where I can just use C1 and C2 if I have those, or this is like a degrading time lord example. After 100 time, I can use any of these and this time. So that is, this is what we want to aim for, like a composability. And if I want to sign for any of these, of these keys, then I would use either, I would create signatures with public key. Participant A doesn't, with a a PSBT support, which is like, I don't know if Andy's here, but he's worked on it. But participant A can just give a signature by understanding if it wants to participate in this policy. Because of Miniscript structure, it can understand this, and it knows that, okay, either I alone can't spend this, and A, B, and C together can spend it, if that is the check they want to do. A can do this check and decide whether they want to sign it or not. And this, if it is a Miniscript, if it wants to check another thing semantically, it can. But otherwise, it can just provide a signature on this, on this script, and the Miniscript finalizer, or the Miniscript, the Miniscript component, which PSBT component, which assembles the witness, can figure out how to create the final witness for the script. You can have signatures of A, B, C1, and C2, and then it will figure out if they are in some tap leaf or if they are some other located in this is another sub-policy of something, and you have all the required signatures. You don't want any custom tooling to figure out what it wants. The finalizer would just look at PSBTs, check the signatures, and assemble the correct witness. So all wallet developers need to think about is forget about the stack, use PSBTs and Miniscript, and just forget about how the script executes. Give it conditions, give it sufficient witnesses, and the Miniscript finalizer will do it for you. So this is, for example, how a simple a Miniscript would look like in a textual format. We would want those. These would be descriptors. So this is a Miniscript, and if you want to just look at semantics, you just ignore these underlying words in here, and you have corresponding semantics. So and these things are softwares can look at those and easily reason about things. Is it possible that after some times, can I spend with my emergency key? Yes. Or if I have A and B, you can spend with these things. So answering these questions is much easier if you have this structure. So I want to revisit the HTLC example. So this is much better to this is what I looked at the script and I hand wrote it. It's not even something which which I use some tooling. There are tools which help you do it for write a Miniscript from a policy, but this is much more understandable to software and to humans to reason about things than something which is specified in Bolt3. One of the advantages here is not only it has structure, but you can write tools which take policy, which is the sum spending policy, and output a Miniscript or a descriptor in case of Taproot, where you have multiple. You can split those in multiple scripts. And the good thing is computers are good at optimizing things. We had experts sitting on trying to optimize Lightning, minimum script weights, but a compiler piece of code actually produces optimal scripts for HTLCs, which are better than handwritten scripts. Same script, similarly for liquid, for liquid sidechain, there were scripts which were written by experts, but computers are good at doing brute forcing and figuring out good things, figuring out optimal things. And this represents average case satisfaction cost for this policy is much better than what you would have in the policy specified. So this is just another advantage for this. But the key point here is, because it is Miniscript, it works with everything else. You have a 3 of 5 multisig. One of them is a Lightning wallet controlled by weird Bolt3 policy. Inside of that is composed and with some other key. And if the finalizer and the updater and PSBT, they understand Miniscript, everything just works. You don't have to worry about opcodes. You don't have to think about script. And if you want to analyze things semantically, you can write software where you can say, can I always revoke with my revocation key? If someone broadcasts something which is a previous state, you can do it. And this is easy to understand. Not only that, it gives you this nice composability, which will help all future wallets you can just interoperate. If you have some custom setup and you want to move to another wallet, you import keys and they don't work. Or you have 2 of 3 and you want to import to somewhere else. But if you have Miniscript descriptors supported, then you just import the descriptors and they will figure out how to spend them or how to sign those. So, ouch, okay. I think I got my old slides here. So in practice, how this, okay, I'll just talk a bit more about the mini policy compiler. So we have this, like with a policy compiler, we can, because we have this tool, that can do more complicated things. For example, like in Jimmy's slide, we had like different ways in which you wanted to spend your policies and have 2 of 2, 2 of 3. You just give it the policy. That will output descriptor. That will give you how to satisfy things. You don't need to worry about how that works. We have done, like Miniscript has done that for you. You just need to know, okay, this is my policy. This is my compiled descriptor. If you don't trust the compiler, you can look at it semantically and see whether that satisfies the conditions you're interested in. It will, that's not implemented currently, music support, but even without that, it will do complicated things like figuring out which things you wanted to place on upper branches, on the upper level of leaves, where you want to place things so that your average case satisfaction cost is minimized. Or if you have, if you add some music support to it, then you can figure out, okay, these keys are music compatible. I can place this as the internal key, or this should be at level 1, this should be at level 3. Because we have the structured, Miniscript is Bitcoin script, this really opens the door for writing different compilers which you want to, if you are interested in. There's one compiler in Rust Miniscript, there is one compiler in C++. You're welcome to write your own thing. And the point here is, after you produce Miniscript, you can do sanity checks. You can figure out whether, this is the policy that you're interested in. Okay, so to summarize, Miniscript is, it's an easier way to write or reason about scripts. Forget opcodes, forget how they work internally. Think about satisfying conditions. It is composable, and you can have generic signing. If, after Darosier's work on Bitcoin Core, that would be one of the wallets which will support generic signing for SegWit v0. And you have BDK or some other wallets who are using Miniscript, and you can create complicated policies between those things, and that will just work. Only the finalizers and the updaters, they need to understand what Miniscript is. For example, if the hardware wallet is, if you have a dummy hardware wallet signer, I know some hardware wallets are interested in figuring out whether the change is spent to them, or if you have some custom signer somewhere, it just needs to sign the PSBT, and it needs to figure out what it is, and just put the signatures in there. The Miniscript finalizer is smart enough to assemble witness from all the signatures, all the hash pre-images, and it can generate things. And finally, script has some weird conditions. There are weird limitations on stack limit. You can have time lock mixing. Even if you have some policy which you want to compile into Bitcoin script, it might not, because of the way weird interactions in script, it might not represent what actually ends up getting executed. For example, one of the paths can have more than 201 opcodes. You look at it, you semantically analyze it, you say, okay, it's good, but when you try to spend it, you certainly can't. The network rejects your transaction. So it statically helps you determine whether such things, whether your script is, can have such things. And actually this, as a boost, this helped. We have fixed bunch of things in the tab script update. One of the reasons for having checksig add is because multi was just annoying to deal with statically. So we have a better opcodes which represent different things. And as I highlighted, we can have policy compilers which output taproot descriptors. So all the examples which Jamie mentioned on slide. Sorry, with good respect to Jamie, you can forget about those. Miniscript will do it for you, Leon. Yeah. And yeah. Do I have anything else? Yeah, sure. I can take a question meanwhile.
Yeah. Does simplicity make Miniscript, obsolete, or are we just anticipating that a lot of people will continue to use Bitcoin script?
So yeah, so the advantage with Bitcoin script is we have Bitcoin script today. If you want simplicity in Bitcoin, that would be another software which you want to do. Simplicity is not ready yet, and people have different opinions, but it will render it obsolete if it ever gets in. It's not at that stage. You can do everything which Miniscript, which Bitcoin script, simplicity can do everything which Bitcoin script can do, but it is not there today. And whether we want that or not is just another, it's a different question where And finally, like there are a lot of people, there's a Bitcoin Core PR by Dorosier here. You can look at the reference and ask for more questions. People have built nice front-end tools which are which help you, like a Scratch-style way, think about script, so you don't have to worry about these things. And you can look at these various implementations to use in your own project. For example, like the Rust Miniscript is used in the BDK wallet project and in CPU. And if you are like a wallet developer, you should use Miniscript because it will help you interact with all of the rest of the wallets in a seamless way. So just make sure that if you're designing a new wallet, unless you're doing something very funky, you are already the scripts you write are already Miniscript. But if you can support Miniscript fully, then you have this generic signing capability where I plug in the future, where I have like a Lightning wallet, one Trezor, one Ledger, one Jade or different wallet, one paper wallet, and I can just work with them. And yeah, that's basically it. Yeah, I'll take questions. Don't have time.